All right, well, we're looking at a topic that hopefully you covered in grade 9, but again, I have no idea what you did in grade 9 math, but we're looking at the slope of a line segment. In our next class, I'm going to show you why we need the slope of a line segment. Now, to start off, again, I'm just going to go over this like you've never seen this before. And what slope is all about, it's the measure of the steepness of a line. Or what I like to call it is, or it is the pattern of a line, which is also true. Now, a formula that we're going to use for slope is something called, it's a nice word formula, rise over run, where your rise looks at how fast or how much your line is going up or down, and your run is a measure of how long that takes. And again, we will get to that. Now, there are 4 types of slope. The first one is what we call a positive slope, which looks like, it's on its way up. It's positive, uphill. And, the next one is, you can also have negative slope. And so if positive slope is going uphill, left to right, then negative slope is going downhill. And of course, in just about anything, if you have something that's positive and you have something that's negative, you have neutral or zero slope right in the middle. And what zero slope is you don't have uphill or downhill. It's just a flat line. Now, our fourth one, we're not really going to look at. It's got a lot of different names. I just call it impossible slope. And that is a slope where, what's the only other way you can draw a line here? Straight up and down. It's impossible to drive up that hill. All right, so we have positive, negative, and zero slope. And again, number 4, we won't worry about, which is impossible slope. What we are going to do, though, however, is find the steepness of a line using rise over run. All right, so for instance, find the slope of the following line segments. All right, now here's the key aspect of finding the slope. You need to find 2 points on your graph that you know for sure what they are. And what I mean by that is if I say this point in blue that I just put in, I know that from the origin, I go left 1, but it's decimals down. So I'm guessing if it's negative 1.5 down or it's negative 1.75 down. I haven't got a clue. So what I mean by 2 good points is points that you know exactly what they are, no decimals. And so there would be a point there for me. And I think this spot right here is a nice point for me where there's no decimals. All right, now what we're going to use is our formula, which is rise over run. So slope is equal to. Now, how I do that is that I am going to connect those dots with just up and down and left and right lines. And in this case, I'm going to go over with my green line, and then I go up with my purple line. Now, my green line represents my run. It's how much I'm moving left and right. And in this case, if I look at my pen, I go 1, 2, 3, 4, 5, 6 to the right. So I put a 6 there. Now, my purple line represents how much up or down I'm going to go. Now, in this case, it's obviously going to be up. And so I count how much I'm going up from the spot that I'm at now because of the green line. All right, so I go 1, 2, 3 up. Now that as a fraction could actually be 3/6. I just had pizza last night, actually, Papa John's. 3/6 of a pizza. If you eat that much, you've eaten half. And there we go. So again, just going from point to point and counting. If I get to number 2 here, again, I need to find 2 nice points. I see one right here that I know exactly what it is. No decimals. Here's another one. All right, so now again, I'm going to find my slope by finding the rise over the run. And it doesn't matter which order you do it in, long as you go from one point to the other. You don't switch. And so in this case, I'm going to go move down. And then I'm going to go over. All right. So now I'm counting my rise, or not lack of one. So let's see here. I count 1, 2, 3, 4, 5, 6. 6 down. So because it's down, I'm going to put a minus sign. And now my run. Let's see here. So this is where I ended up, right at where my purple and my green meet. And I go 1, 2 to the right. 2 to the right. And now actually, this is another fraction I can write out. -6 divided by 2 is actually -3. And now here's another key aspect, is that slope does not need units. There's no units required because it's just a rating. It's how big or how steep or how not steep your line is. So there's no units. All right, so I get to number 3. Again, I need to find 2 points. I'm going to say this one over here is a very good point, no decimals. And there's one there as well. Again, any 2 points will work as long as they're good ones. There's no decimals involved. All right, so now I'm going to find my rise over my run. And so I'm going to go from this point here over. Let me see, I go over. All right, and how much did I go over? Let's see, 1, 2, 3, 4 to the right. And then I've got to go up from there. So let's see, I go 1, 2, 3, 4, 5, and 6. And so I get 6/4. All right. Oh, it actually could be reduced to, as a fraction, 3/2. Now, something I mentioned here was that the slope is the pattern of the line. So this slope being a 3/2 is telling me to go from dot to dot, up 3, but right 2. So if I go to my blue dot, I go up 3, right 2, and look at, I found another point on the dot on the line. Up 3, right 2, and there's another point. If I continually followed that pattern, I would follow, or I find my lines, all the points on my line. All right, let's try and call a few more here. Number 4, again, looking for 2 nice points. Well, there's one right there. And this one here looks pretty good. All right, so again, finding my slope. I'm going to, let's see here, go down a couple. So down 2. Now again, I'm going down. Down 2. And then I'm going to move over, see here, to the right. 1, 2, 3, 4, 5, 6. 6 to the right. And again, if I was to reduce this fraction to lowest terms, I could divide both the top and the bottom by 2, and I'd get -1/3. So it's saying the pattern of this line is down 1, right 3. Well, down 1, right 3. There is a point. Down 1, right 3. And there again is our other point that I used. All right, number 5. There we have our line. Now, there's no need for me to do rise over run in this situation. It's a flat line. And so, because it's a flat line, the slope is just simply equal to 0. It's neither downhill or uphill. All right, then last one here. Well, not last one of these guns. Number 6. Again, I'm going to find a point here. There's one there. And there's another one right there. Now, this time, I'm going to move from right to left instead of left to right, and it still works. So here's what happens is that I'm going to go down here. So I go down 1, 2, 3, 4, 5, 6, 7, 8. So my rise is down 8. But now watch this. I'm going to go left. 1, 2, 3, 4. Because I went left, it's a -4. So up and right are positive numbers. Left and down are negative. Now, in this case, these two negative signs cancel each other out. And then I end up with 8 divided by 4, which is just 2. Now, as a fraction, 2 is 2 over 1, or 2 divided by 1. For the pattern of this line, it says then, if you want to go from point to point, you can go up to right 1. Well, check it out. Up to right 1. Yeah, there's a point. Up to right 1. There's another point on the line. Up to right 1, and then up to right 1, and there's our other point. Now, something to notice. All of our numbers, all our slopes that are positive, the line they're going uphill. For all the graphs that have a negative slope, the graphs are going downhill. But you can see in this one where we have a slope of number 2 here, where we have a slope of -3, the line is very downhill. Where if our slope here is just -1/3, which as a decimal is -0.33, it doesn't go downhill as much. So the size of your slope indicates how steep it is, either downhill or uphill. And of course, your sign tells you whether it is uphill or downhill. Or in number 5's case, it's a flat line, so it's neither. All right, here's something interesting. This is actually true, by the way, is that oceanographers have found that a wave tends to fall over or break when its slope becomes greater than 2/7, which as a decimal is 0.2857. For each wave shown, determine if it would break. So we get 2 waves here. And again, I'm going to use my formula rise over run, where along this wave here is our run. So that would be our 2.8. And then we go up, which would be 0.5. And so now I can take those numbers and divide them. I can take my 0.5 and divide it by 2.8. And I get 0.1785. That's a lot of numbers. And that is less than our 0.2857. And so the wave won't break, won't fall over. All right, let's check out B here. Again, I have my run, which is your left or right number, in this case to the right, which again is 1.9. And then our rise, which is going up here, 0.6. All right, now let's see. Again, this is true stuff. I got this out of a science book. 0.6 divided by my 1.9. And this time I get 0.3157, which is greater than 0.2857. And so that means the wave will break. There we go. And just a little different information there for you about waves is that in the summer and the winter, because the wind is different, it changes the waves. And so the waves change according to the season. And so some waves put sand on a beach, and then in the winter, the waves change and they take the sand off the beach. It's really cool how nature works. Well, again, useless information there for you. All right, in the graph below, the height of the snowboarder is recorded as they snowboard down a hill. Not looking forward to this season. Find the slope of line W and Z. All right, so we'll start off with W here, which is my red line there. All right, so I want to, again, find the slope of W. Now, this is a little bit different. I'm going to show you why. We are still going to use rise over run. So again, with my W line here, get rid of that red line. I'm going to go over. I got 2 points, by the way. I'm going to use the end points. So let me put those down, the start of W and the end of W. It's the same thing when I do Z. I'm going to do the start of Z and the end of Z. But I move over and I'm going over 1, 2. Okay, so I got 2. Now, here's where things change up a little bit. I'm going to go down 1, 2, 3, 4, 5, 6. But here's the difference with this graph. I'm going down 6 spaces. That is true. So I'm going down, it's going to be negative. But look at this snowboarder is dropping from 700 down to a height of 400. So in fact, before all our spaces were just worth 1, but this time they're not. They're worth quite a bit more. And so this drop is, if the difference here between 700 and 400, if I subtract those two, I get 300. And so this snowboarder is going down 300. So you got to watch out for the units on your axes. Now, if I take negative 300 and I divide it by 2, the slope is negative 150. All right, I'm going to do another one of those. I'm going to do the slope of Z. Again, I'm going to use rise over run. All right, and so again, I'm going to go from one point to another. So I'm going to go over. Now I'm going over 1, 2, 3, 4. And you can see on our axis, each space is actually worth 1. And so I'm going right 4. And now we get to the drop. Now I don't bother counting the spaces because it doesn't matter. They're not worth 1 each. So I started off here in between 400 and 500. That would be a height of 450. And I end up at a height of 0. And so my snowboarder has dropped 450 meters. And let's see. Now these lines both look steep, but the slope will tell me exactly how steep it is. So I take my negative 450 and I divide it by 4. And I'm going to end up with 112.5. Oh, and don't forget the negative side because, well, clearly a snowboarder, we're going downhill on this one. And so the slope of W initially, it's a steeper hill than when the snowboarder goes downhill Z here. And there we go. So again, with slope, we're using rise over run.